What's up, Algebra 2? Here we are with our trig identities, verify and solve. We're going to do the verify part today. We're going to advance to the solve part tomorrow. Okay, so these trig identities on the top should be old news. Tangent equals sine over cosine. Cotangent equals cosine over sine. Secant is the reciprocal, or 1 over cosine. Cosecant is the reciprocal, or 1 over sine. Cotangent equals 1 over tangent. Okay, here's some new ones. We got sine squared plus cosine squared equals 1. Okay, that's coming from your unit circle. Remember geometry, x squared plus y squared equals 1 for a circle with a radius of 1, because it equals r squared. And if you remember your unit circle, sine is more like the y, and cosine is like the x. This is kind of flip-flopped from that x squared plus y squared. This one's y squared plus x squared equals 1, but this would be more like the equation of a circle. And then we have two more, which I'm sure you're not going to be happy about, but these two are this one. They're the exact same, just different representations. What do I mean? Okay, sine squared plus cosine squared equals 1. What would happen if I divided everything over here, or everything on both sides, by sine squared? Or if I divide everything by cosine squared. Let me get the page up for you here. Okay, if I divided everything by cosine squared, sine squared over cosine squared over cosine squared, 1 over cosine squared. Sine over cosine is tangent, so sine squared over cosine squared is tangent squared. Cosine over cosine is 1. 1 over cosine is secant, so 1 over cosine squared is secant squared. And that is how we get the next one. Okay, if I divided everything by sine squared instead, we would get this one. So they're all the same thing coming out of this. Okay, when we're verifying today, verify means to show or to prove that they're equal, show that they're equal. You want to pick one side to work on and show that it equals the other side. You want to start on the more complex side and simplify it to the other side. Okay, it's easier to take something that's complicated and simplify it down versus start on the side that looks really simple and then try to expand it or complicate it out to match the complicated side. We can substitute using our identities from up above. Probably going to be focusing a lot on these today, the new ones, but still using these. We can factor. Oh man, factoring or multiply out. You can already see one here where it's already factored, but we need to multiply it out. Another strategy, if you get stuck, is to change everything to sines and cosines. Change everything to sines and cosines. And do not perform operations to each side. When you multiply both sides by 3 or divide both sides by whatever, that is the multiplication and division property of equality, because you can do it to both sides of an equation, of something that's already equal. We are proving that these are equal, so we can't use the properties of equality. Okay, if we're just working on one side, we can multiply like this by sine over sine, because sine over sine is 1. You can multiply anything by 1, but we can't multiply both sides by sine to try to change it. Okay? Let's get started. We got secant squared over tangent equals cotangent plus tangent. Okay, there's not really an obvious one as to which side is more complicated. I'm going to go with the left side because it has a squared. Okay, so I'm looking at, I see secant squared, and hey, that sounds familiar. We just learned something with that. Secant squared is 1 plus tangent squared. So we'll have 1 plus tangent squared over tangent. I stop writing the x's or the thetas because then they just get in the way. If you want to keep using them, you certainly can. Okay. 1 plus tangent squared over tangent. Now the next step with this one is a step that's so simple it's going to get overlooked. And in fact, we usually try to go the opposite way. We usually try to get a common denominator to put two fractions together. Here we have a common denominator. I'm going to pull them apart. I'm going to pull it apart to 1 over tangent plus tangent squared over tangent. Okay? Tangent squared over tangent. If you think about what tangent squared is, it's tangent times tangent. And then we have a tangent on the bottom. So that will simplify to just tangent. On the left, we got 1 over tangent. 1 over tangent is cotangent. And that matches what we were trying to get. And we're done. Okay? We verified, we showed that this is equal to that. After you get done with it on one side, you can kind of reverse it and see how you could have done it the other way. We could have changed these. We could have got a common denominator and then put it together and then had secant squared over tangent. Alright, let's have you do this one. Before you get fully into this, we're going to foil that out. And I should point out that you might be seeing these in different versions. Like you might not always see sine squared plus cosine squared. You might just see cosine squared. Well, cosine squared, I could subtract the sine squared over, is 1 minus sine squared. Or maybe it's just sine squared. So if we needed sine squared by itself, we could subtract the cosine squared over, and we might see 1 minus cosine squared. So you can move these around. You can move these around to get one of them by itself or a different one by itself if the one you currently have doesn't work out. Alright, so I want you to go ahead and push pause and give that one a try. Alright, let's check in. Okay, after we distribute, we should have 1 times 1 for 1, minus sine, plus 1 sine, and sine times sine is minus sine squared. Minus sine and plus sine will cancel out. We'll have 1 minus sine squared, and we can come up here and work this one. We'll find 1 minus sine squared is cosine squared, and that's what we are trying to get to. And that's what we are trying to get to. Okay, if you're going to go the other way, you could do cosine squared equals 1 minus sine squared, and then we'd have a difference of squares that you could factor out to be that, and there you'd be done. Backside. Okay, the backside we're going to work on. Using sines and cosines. Okay, we're going to change them all to sines and cosines. So we have sine squared and tangent squared. Remember, tangent is sine over cosine. We're going to change that was tangent squared, so we're going to have sine squared over cosine squared. Okay, now thinking ahead, tangent squared is going to be a fraction. How can I write sine squared as a fraction? We're going to go sine squared over 1. And then for our tangent squared, it's sine squared over cosine squared. Okay, tangent squared is sine squared over cosine squared. Sine squared, we changed it to be a fraction so that it would match up with this a little bit because we're thinking ahead. And we have sine squared over 1. Fraction divided by a fraction, we're going to change it to multiplication and flip the bottom one. Now the cosine squared is on top, and the sine squared is on the bottom. Okay, sine squared on top, sine squared on bottom will cancel. And all we have left is cosine squared over 1, which is what we are trying to get to. Okay, you're going to try this one with the same strategy, changing everything to sines and cosines. Let's hit pause and give it a go. Alright, let's check in. So tangent squared, I went with sine squared over cosine squared. Cosecant squared is 1 over sine squared. The sine squareds cancel out. We have 1 over cosine squared. And maybe you got stuck there. 1 over cosine is secant. So 1 over cosine squared is secant squared. And then we had another formula, secant squared, one of our new ones, secant squared equals 1 plus tangent squared. And that's how we got it. Boom. Okay, the other two are primarily challenge problems. And depending on what class you were in, maybe you got to do one as a class, maybe we didn't, depending on how time went. I'm trying to find a good one here. We can... Here is the left side that we could talk about. Okay, it was equals blank. Mr. Handke forgot to write down the other side. Equals sine. So we have secant over tan plus cotan equals sine. So I went with the strategy of changing everything to sines and cosines over here. 1 over cosine, sine over cosine, cosine over sine. I'm seeing two fractions, and when I see two fractions, I kind of want to put them together. So I'm going to get a common denominator. They are totally different denominators right now. So I'm going to multiply this one by sine over sine, and this one by cosine over cosine. And that will give me a denominator of sine cosine. Okay, what it also did is it gave me sine squared and cosine squared. And sine squared plus cosine squared is 1. So we have 1 over cosine over 1 over sine cosine. Fraction over fraction. Flip it and multiply. The cosines cancel out. And we have sine left over, which is what we want on the right-hand side. Okay? The other problem on the other side is pretty complicated. Maybe a little bit more complicated than I wanted it to be. So I'm going to leave it up here, and you can take a freeze and take a peek at it if you want. But I would not get too worked up about this one. You're not going to be seeing anything like this on a quiz or a test. Okay? All right. So there you go. The nature of these problems is primarily going to be more like the first 4 that we looked at. Not like these, but it isn't a terrible thing to push your mind every now and then. All right. Thanks for watching. Good luck. Let me know if you have any questions.